Hello again. Okay, now we're ready for our fourth experiment. Now the driving force has been increased to its maximum value, okay? And you can see the motion of the pendulum looks quite different now. First we have very large amplitude motion, so large that the pendulum bob sometimes goes all the way over the top of the physical pendulum. And notice that when it does that, the restoring force becomes really crazy. It actually switches sign at that point. Okay, and finally you can probably see that the motion of the bob is no longer really regular. It's no longer predictable. We've entered the chaotic zone. Here, let's go ahead and collect data for 100 seconds and see what it looks like. You ready? And we're off. I'm just going to auto-scale the phase plot here. There we go. And you can see what it looks like. We'll just let this run so you can watch it. All right, well now we're done. Here I'm going to stop the recording for a second. And let's take a look at what we see. Here I'm again going to bring the camera up to the monitor. I hope that makes it easier to see what we're looking at. First of all, when you look at the amplitude as a function of time, it looks completely different now. It's no longer a regular sinusoid. It isn't even a sum of different sinusoids, although it looks like it in this region. But if we look across the wider region, we can see that it's really unpredictable, okay? Look at the Fourier transform now. The Fourier transform does not have a single peak at a well-defined frequency. Instead, it has frequency components all over the map. Another hallmark of chaos. And finally, let's look at the phase plot. This looks very interesting too. Instead of a circle or an ellipse or an egg shape, we have this bizarre shape here called a double scroll. We can interpret this pretty easily. When the pendulum is in this mode, it's oscillating about one center of motion. When it crosses over to the other scroll, what's happened is that the pendulum bob has gone over the top, and now it's going to oscillate about the other minimum for a while before it gets kicked back over. These are sometimes called basins of attraction. In any event, this double scroll pattern is classic for a particular type of chaos. Okay, very good. Let's stop the recording now, and we're going to do one more measurement after this. And that'll be a measurement of the same system under the same conditions, but recording for a much longer time.